For those of you who watched this stream live, I have to apologise. My voice came out really, really deep because unfortunately I was sampling at 48 kilohertz on the audio recording thing and streaming at 44 kilohertz, and all the processing that went in between meant that it sounded really freaking weird. So I apologise for that. I've corrected it somewhat in post, so hopefully you can still enjoy it. Hey guys, hopefully you can hear me properly. I don't need these because I can hear myself. Hopefully you can hear me properly. Welcome to the stream. We've got a few things to run through today, but as I said in the last stream, I'm not really sure what these streams are going to be about yet. So I'm just sort of fictions really. I'm just going to see who's in the chat. I saw a few people, so let's have a look. We've got Eric's here, Ashley's here, Gregor's here. We've got Robert, Jonathan from Sweden, Johan, sorry, I apologise. Johan from Sweden. We've got Peter from London. Hi, Peter. Peter Carlisle, is that right? I think that's right, it looks right. Jim Connors here. Tau Cars, okay, hello. Not sure what that word means, but if that's rude, then I'll ask someone to be a moderator and get rid of that. Okay, let's get started. So today I've got a few little electronics projects to sort of show you, stuff that I've been thinking about and a little bit of advice. Oh, and I've got something which is kind of exciting. So first off, let's have a look at what I've got on the bench at the moment. Is that right? Let's have a look. No, that's wrong. Let's go for that one. It is the right one. Good. We have, I'm using a little lavalier microphone, Eric, because I don't have one of the, you told me about this big microphone that you had. I don't have one. Also, Eric, if you can tell me how to get the comments up on the screen. So we've got these little Max 7219 8x8 matrices. I picked these up on AliExpress. They were pretty cheap. Now, I showed them in the last stream and I said what I was going to do with them. I was going to try and turn them into sort of a spectrum analyzer, visualizer. So frequencies. Sorry, that's not really in shot, is it? So it would show frequencies. Unfortunately, these ones don't work as expected. So let me show. I've hooked one up so you can have a look. So let's just pop that on top there. So actually they sort of show up like this. Now there is a problem with them. Let's have a, if I take one of these out, they should come out red. So the Max 7219 is it's a 7-segment display driver, but actually it's used for 7-segment displays, so like it's used for matrices. And matrices, like this one here, have all the pins on the bottom, and they tend to be anodes in rows or cathodes in rows or columns. And unfortunately, these aren't all equal. So I've got another one here. Let's just pull this one off. I've got another one here. It's exactly the same model. I've looked at the wiring under the board underneath, and it's exactly the same. There's nothing different about it. But I think the display is different. So this one, I can't do it. This board I tore out of my little Pi bot. This dude here, he used to calculate pi. There's a video on my channel, you can have a look at it. He used to calculate pi, and he had a little face. So let's just use his one. And if I pop this on, you'll see that this one works perfectly. So there we go, you can see that this one has a display. Now you might think that I've got it the wrong way around. And I can show you that the other way around, we get this weird pattern. And that's because it's cathodes and the anodes the wrong way around. Now, if I just pull that back out, oh no, I hope I haven't got it stuck. Oh, I have done. Oh, there's a tricky. Now these are the modules that I picked up, which look largely the same. Now if I put this one in the reverse position from where they gave it to me, you can see that I sort of get some kind of pattern going on there, and you can see that they're moving the display that I need it to. Now, again, you might think I had it the wrong way around, so let's just turn it around, and then you'll see that they're all lit up. Now, I think this is a problem with the way these little are wired up, but I haven't figured out how to fix it yet. So if anyone's got a clue, that would be brilliant. I'm just using a library called LED Control. You can find it very easily on the Arduino website. It's one of the ones they sort of promote. There are lots of others out there, but I can't find any that reverse the anode and the cathode instructions. So that's when it sends binary data to the max, it reverses them, or it drives the different columns and rows differently. So instead of scanning the columns, it will scan the rows, that kind of thing. So I thought it was a little bit interesting that these aren't the same. So you can pick these up. For example, this is came with this display. So this is the one I was running before. It's got a slight different makeup. I had to make this one. It came as a kit, so I had to solder the parts on. But it's exactly the same. The board is exactly here that the, I don't know if I can get a bit closer. I turned autofocus off, but you can see that it is wired exactly the same. The traces all run exactly the same, but the displays behave differently. So it's down to these. Now, hopefully, it's not a hardwired problem so that we can't sort it out in software. I'm not sure, but if not, they're only £4, so it's not the end of the world. Right, let's have a quick look. If any of you guys have had... Oh no, don't tell me there's something wrong with the stream. If there is, I'm probably never going to stream again. Let me just... I'm sort of watching the stream as well, so I'll just pause that. So yeah, if you guys have any ideas on how we could fix this little problem, I mean, I have Googled the hell out of it, but unfortunately no one's come up with any answers. Someone did mention something about them being different. What was wrong? Do I need to... well, the lip sync will be slightly off. Let me just try and fix that. A little bit there. So, settings. Is it ahead or is it behind the audio? I know there's a really sort of long delay. Right, while I wait for someone to answer that so we can sort the issue out, I'll just have a little drink. I think it's Eric's fault that I drink beer on stream. I can adjust the delay in audio recording, I think. I'm not sure. In fact, I'm not going to bother because I'll do something wrong and then it'll go. Video's behind the audio. That is mic sync offset milliseconds. Right. I've delayed the mic a little bit, so we'll see what happens there. But yeah, I will blame Eric. Okay, so I just wanted to cover a little bit of that, of these sort of modules, because I think it's something that people will come into, it will happen to people that they'll pick up these sort of what are seeming, except they don't behave the same. I mean, I can try a different board and we can have a look. So if I just take that one out, you'll see that the Oh, that's not in the camera bit. You can see that the pins are this one straight in. And if I plug the same display back on, oh, wrong way. Is that the wrong way around? Something's happening here. Do you know, we might actually have solved this live, potentially. So we've got clock, load, data in, ground and VCC. And correct, the only things that could be wrong or the wrong way round are clock and load. So let's bung this on in the way that I think it's meant to go round. I realise that live troubleshooting might be interesting. Or is it actually worse? Okay, I'm going to stop messing around with it. I'll put it back. Okay, I think maybe that has fixed it. I'm sort of live troubleshooting this. So I'm going to try and switch the clock and the load lines around. And we'll see if that makes any difference. And we'll just reset the controller. No, what is going wrong there? It does not like that. Let's pop those back. I don't know how I've managed. Screen's wrong on the board, I'm not sure. No, again, it's not liking that. But it isn't a simple fix. I did try for hours last night. I'm not even kidding. I went to bed at about 2 a.m. after playing with hours and hours and hours. Well, now I can't get it to behave at all, so let's try it with this one. I'm gonna skip over this because unfortunately I don't have a solution for this. And that is one thing that I wanted to talk about was troubleshooting, because there's a couple of dudes that have been doing some stuff recently and I've learned a lot from looking at it. So is that the correct one? It is. So you all know who Dave is from the EEV blog, and I'm sure you watch a lot of his videos. Some of them can be really long. You have to invest a lot of time into Eric's videos. Sorry, I've got Eric on the brain. Into Dave's videos. So this one was 50 minutes long, and this is the second part, and the previous one was about 35 minutes long. And this one, he goes through troubleshooting an oscilloscope. Causes. I won't spoil it for you, but it's a really great little journey into troubleshooting through schematics. And that's what I hope to do with those little modules. I'm going to try and map out the schematic, create my own, draw it on a bit of paper, and I'll figure out where all of the lines are going and why they don't work with these little. Do is I'll just hook up a resistor to one end of those pins and drag, hook it up to 5 volts and then drag a ground cable across and find out where the pins are. So see which side is anode and which side is cathode. But he had a great video about problems that you'll generally find. These are in more complex systems than these little matrices, but it was interesting. He's very tenacious about searching for these problems. And then something like this happens where he's got the manual and he's just read that, and actually it's really best place, partly because all people that play with electronics, perhaps engineers, hobbyists, are slightly arrogant, I think. I certainly am. I think I know what the problem is. I spent an hour thinking it was a coding problem before looking at the hardware. So, I think. These, it is a little ultrasonic sensor. Now, I've had these before, but because I work for a university, I lend a lot of things to students, and I didn't actually get it back from the student. So I picked up one, and I also picked up something else because we're going to be making. I'm so fickle with projects. You know, in the last stream I mentioned loads of projects that I was doing, and I'm not entirely sure how many of them are actually going to pan out. But this one I'm hoping will. And I also picked up this little thing here, which I can get it out. It's got some, well, it's a little mount. You can't see that, there you can. It's a little mount for these thingamabobs. Does it go the other way around? Well, I say it's a mount, but it actually doesn't fit in. So this is another buy from AliExpress, I think. Oh, there we go. It does fit. So it then has sort of these little mounting holes on the top so that you can connect it to a servo or something like that, so that my little robot can sense distance, which is very exciting. But that isn't all. I have also this second screen. Yeah, that it's probably that one. I've also picked up this, which is a sort of a well, it says is it depth of field? It can't be depth of field, can it? DOF? Anyway, 2 servos. It's stationary, and the top spins like that, so it's got horizontal movement. And then the other one sits on top on its sort of side, and then it has sort of vertical movement like that, so that you can have, love the hand signals, right? So it can do sort of that. God, can you imagine if the sound went out? It'd be like some kind of YouTube streaming puppetry thing. So it would. So basically, it's going to be the eyes for my robot, and it's going to be using this webcam that I was showing desktop stuff with. So it's going to have its eyes as a webcam, and we're going to be to interface with it. Let me just turn the audio up because I can see that I'm just a little bit low. That should be a bit better. So we're going to use the Raspberry Pi to interface it with it using OpenCV. And hopefully it will work out. Webcam full screen. I'm trying to figure out which one I have to put on. Let's go for that one. It is that one. So I'm hoping I'll be able to connect this up with the sort of 3 degrees of freedom. Thank you, Ashley. You've just put that in the comments. 2 degrees of freedom sort of thing. Let's just, it's pan and tilt, isn't it? 3 degrees of freedom pan and tilt thing. Hook that on the bottom of it, and I can put the webcam on the top. So this will go on the bit that sweeps side to side, and then the webcam can go on the top so that it can act side to side. Because I'm not worried about this going up and down. It's pretty much going to be a bit of a stationary robot for now. I have decided to make a base for it. I was going to buy one. I posted on Google Plus that I was looking to buy one. In fact, I might have, so that I can show you. Let's have a quick look. I don't know if you can hear my mouse wheel furiously scrolling away there. No, I haven't bookmarked it. But that's one of the projects that's coming up if if it materializes. So I've finished reading your comments now, but we've got to the bit where people are starting to answer what they think it is. James B says it's a resistor ladder. Ashley says it's a coffee maker. It might well be. Do you know, I've got this little guy here. I'm going to show it to the thing there. This is, I don't know if it's going to focus on that. That is Lionel Richie coffee. Demetrios, it is an LED matrix. And Mr. William, I don't think that's an appropriate suggestion. And Andre says it's an 80 mega plus LEDs. You are absolutely correct that I was making these these things. I find them so frustrating to use. They're great in that they have the Max 2719 on here, and they're nice that you can daisy chain them, but you could do that anyway off head a bit here. You don't need this sort of coming off the side, and they're kind of cumbersome. So I wanted to design something that was, well, I'm going to say a bit more me, but really I just wanted something that I'd created. So if I zoom in a bit on this one, you'll see that we've created a little bit of a matrix here. Hours, I'm not even kidding. I was fuming by the end of it. Why did I started it on a Sunday, so I think I started it around 6 o'clock, and I think I finished it around 2 o'clock in the morning, which meant I got to sleep at about 3 in the morning on a Sunday. When I had to go to work on the Monday, I was fine. I got in. It was okay. But an LED matrix, I'm hooking them up with 74HC 595s. Now, this isn't the ideal way to do it, but it's going to work. The problem with these 74HC 595s is they don't sink an awful lot of current, so it's about 20 milliamps. But I don't want this to be like a power-hungry LED. LEDs on there with relatively high current limiting. So probably around 460 ohm resistors, maybe 470. I can't remember what the standard is. I think it's probably 460. Maybe even higher than that. I will test the LEDs to see how bright they are. The problem comes with that when you're doing persistence of vision. If they come on and off really quickly, then you won't get a really clear persistence of vision effect. And that's what you need when it comes to these 74HC 595s, because you're only going to be driving one LED at a time. But I think it's achievable because I've done it before with LEDs on a breadboard. And in fact, I did a boombox a long time ago, and that was in a 7x7 matrix, I think, or a 7x5 matrix, which is kind of similar. So I think it's going to work. Anyway, this is the schematic. Oops, I need to drag that out a little bit. So we have our matrix just there, and if I scroll across a little bit more, we've got our AT Mega 32.8p. That's not how you meant to say it, is it? It sort of rolls off the tongue a bit more, I think. Anyway, it's the SMD version, so we're going to be using that. It's going to have no USB comms, so it's just programmable via the programming headers, so SEK and power and ground and whatnot. So we'll just program it like that, and it's also got the TX and the RX. That's for doing the bootloader, and TX and RX for programming later on using a little USB TTL thingy. And then we have the board. Now this is the bit that took the most time. Honestly, how long this took? Well, it's probably about 3 hours, but routing this board, so they're all SMD LEDs. These are 1206 LEDs. And I routed this board on Sunday. It took forever. And as you can see, there are an awful lot of wires jumping across these LEDs. But it had to be done. Unfortunately, there was no other way to get around it if I wanted to have a chip on the board itself to make the board, what is it going to be, 52 millimeters by 52 millimeters. Now that is roughly the same size as the little board that I created for the portable AT Mega. That I would have this portable AT Mega, and on the back I would have this LED matrix, but it was totally not possible. So I had to scale my ideas back a little bit, which I often have to do, and just settle for having an AT Mega on here that I can break out a few pins on, but also maintain the matrix. So it is 50, and if I just click on the rat's nest thing, it should look a bit more clear about the routing problems that I had with this one. So a lot of these areas are going to be sort of etched out. But if you look down here with the chip, I don't have room to bring out many of the pins. I'm having to sort of be very clever with wires, and certainly with this one here, it's a ground wire, and they've become incredibly necessary with this board. So there's quite a few of them dotted around, and getting these larger pins in for sort of single pinhead things has been a bit difficult. So that's the idea with this. It's got a button on there for reset, but it's also got a button for changing the mode. We've got 3 pins at the top here, and here because I can't route the pins needed to control the 74HC chips from the ATmega on the board itself. So they're having to come off with little jumper wires, which, you know, sort of broke my heart to do it really, because I wanted it to be completely self-contained, but it hasn't ended up being. So I will post this board once. I'm waiting for it to come back from OSH Park or OSH Park or whatever you want to call it. And when it does, and if it works, I will post this up on GitHub for everyone to play around with if they want. I think, do you know, one of the most useful bits about this project for anybody that wants to play around with it is probably pre-done in Eagle, because that does take a while. Copying a row, putting down a row of LEDs and then copying them and pasting them, copy and paste, then routing them all up, and also finding the part for the 74HC595. You have to invoke the pins so that you have VCC and ground broken out, and you have to stick in caps and stuff, so it's a bit of a nightmare. And even, I suppose, routing the board itself is, well, it was painful, because if you imagine routing, let's jump to the routing bit and you can have a look. So these are on the bottom of the board. So the top of the board has my chip, because it was the last thing I was going to route, but I routed it as the top of the board. Then I mirrored all of that stuff. And what the biggest problem was placing these so that they absolutely lined up with all of the rest of the LEDs. Because you can imagine if you had one slightly out, it would be so noticeable. And for someone like me, it would just really hack me off, I think. That it was going to the properties of each one of these. And in properties, you can see that you can set the position on the X and Y. And so I had to manually type in the position for 64 LEDs, which honestly was a real job in itself. But luckily I was watching some people stream games on YouTube, so I could do that. But yeah, OSH Park are going to be sending this to me probably in the next few weeks, and then we'll do another video on it. Maybe it'll make it into a live stream if I continue doing these. So we'll see. If I come up with a good enough format, then we'll do that. Right, I'm just going to talk amongst yourselves while I catch up on the chat, because sort of segue into the reading the chat bit yet. In fact, what I can do is just pop the music up a touch so you've got something to listen to. It might be really loud, I'm sorry. And I will read the chat. Ashley says, wait, you're having coffee and beer at the same time? Yeah, I think they cancel each other out a little bit. Wake and the Bex relaxes me enough to do the stream, if I'm honest. You guys make me nervous. Andre, I get them done at OSH Park. I wanted to get this one done at Dirty PCBs, which is a new one you can go to. But they starts at 50 millimeters for their cheapest one, and then jumps up to around $24, I think. And so it was, although they give you 10 prototypes, but I don't have the LEDs. I don't have 640 SMD LEDs. So I just wanted to go to OSH Park, get 3 done SMD LEDs. They're not massively expensive, but I also don't have 100 ones for each board, so I didn't want to buy like 300 lots of 100 resistors. So that's why I'm going to OSH Park. But Dirty PCBs is a place I'll try out for boards smaller than 50 millimeters square. In the last, I think Ashley's just said it's not that hard to do SMT at home. Actually, what's the difference between SMD and SMT? I don't know. I use them interchangeably, but I don't know if there's an actual difference. SMD stuff is easy. I think the difficulty is if you're used to through-hole parts, then the way you prepare your boards is different, and the way you go about putting in components is different. So with SMD stuff, I tend to solder a single pad first. So let's jump down to the camera and I'll show you. So on SMD, like this board here, I would solder a single pad like that one there. Let's try and get it in focus. Hang on a second, let's just... Okay, right. An SMD board like this one. So this one's pretty complicated, really. I mean, you've got this tiny TQFP, whatever the footprint is. It's like it sounds like TQFPN or something like that. Someone will know. But this is the ATmega 32U. No, the ATmega 32U4. So they're real, but I have like a little secret weapon when dealing with these SMD boards, and it's this, which is a little flux pen. It's just like a marker pen, and flux comes out the end of this this bit here. Oh, I just touched it, brilliant. Just wipe it on myself, not a problem. And so what I do is I pretty around here with flux. That cleans the contacts, but it also enables the solder to flow really easily over your bits. But first, when you're putting on your chip, you want to tack down one edge first on one of these big chips, and then you can just heat that up to maneuver the board around this bit to line up the pins to your sections here. Similarly with little capacitors and with resistors, put a bit of solder onto the pad itself and then put your resistor on top of it. Then you can heat up that solder and the resistor will, let's say, stick. It's probably not going to be the best joint, but then you can solder the other side quite easily and then come back and tackle the other one again if you need to. So you do one side and then the other, but first you have to sort of bit of a little tiny mound of solder, maybe even less than that, and then you can push your part onto it. And that's pretty much all you need to worry about with SMD stuff. If you end up over soldering, which is, I did that with the first one of these that I did. So if you look at the other video, you'll be able to see that. But if you end up over soldering, you can use, luckily I'm actually sat, I don't know where the thing is that I'm looking for though, mine. Have a quick look. No, I can't see it, but it's called Solder Braid, and well, I think it's incorrect, but I can't see it. It should be relatively easy to see. I mean, it's not like it's not oh, there it is. No, it's desoldering wire. So desoldering wire, and you'll see this one's a bit sort of messy. It's essentially like a copper braid, and it sort of comes out from this thing. The wrapped, very thin copper wire, and when you heat it up, it will suck up solder like you wouldn't believe. So if you over solder an area, you can use this. You can also use a standard little solder sucker like this. So they're pretty well used for through-hole parts, but they also actually help you out with SMD stuff. Your resistors into this, so maybe they're not the best, but that's about all I can really tell you about SMD soldering. I was going to do a little video on it, like a little step-by-step with some resistors and with some larger components like the inductor, which is on the top there. That's a bit of a difficult one to do because you need to apply quite a lot of heat. And when you slide that component underneath, so they can be tough. A reflow oven would be so much better for some of the components that would have been on this board, but I don't have one. You can make one out of a little home oven, but if you don't have the space, then you can sort of settle for other things. Solder wick, Andre says. Yeah, that's correct. I've got, mine says desoldering wire, but I guess it's like a regional thing maybe. Let's see. I'm just going to catch up on stream on the thing again. James says TQFP, thank you. I knew it was something similar to what I was saying. It certainly sounded correct in my head, but it wasn't quite. I wonder if anyone's told me what SMT and SMD difference. Ashley says you might want to look at what OSH's limits are. I use ITEED and can use traces as thin as 6 mils and drill holes for vias as small as 10 mils. Actually, I think OSPark have if you're going to be using rules in a file you can load into Eagle, and when you do your design rules check, so let's jump back here. So when you're in Eagle and you click this little design rule check, it'll pop up with a little window and you can click check. And if, say, you had too thin of a trace or one of your vias was perhaps overlapping like that, put up the design rules bit from here. So if I go to Documents, Eagle, and then it's called Lane PCB Order, and if I open that one, click check, it will tell me that there's been an overlap and do that. I'm sure I'm, teaching, it's like teaching a grandma to suck eggs. You basically know all of that already, I'm sure. But other people might not know that you can get these design rules. In fact, it's just design rules so that you're sure that your board is going to be able to be produced properly at the factory. You guys have written loads of comments. It's really hard to keep up. I mean, thank you. That's really nice. I'm glad you're all talking. It's good. So you're not asking me questions, which is good. Well, good, bad, yeah, I don't know, whatever. It just means that me not noticing whether the chat's gone nuts isn't too bad of a thing. Ashley says, thank you, by the way, for answering this. SMT, surface mount technology, SMD, surface mount device. So they're sort of similar, but one's the way it's mounted and the other one's actually a thing that is mounted in that way, I guess. Is that correct? Yeah, you're right, Ashley. Each design house does have its own sort of DRC rules, but thankfully a lot of them provide the things for you so you can check. But it's always good to know what the rules are before you start designing something. So for example, this board here has quite thin traces and might not have been designed elsewhere, but I know that OSHPark can do it, so it's good. Okay, what else have I got? One more thing, and then we're going to look. Actually, let's have a look at the results of the straw poll first. So, at the moment, overwhelmingly, we've got 9:30 as a suggestion. I think someone else has suggested something in the chat, so I'll check that out in a second. So that's good to know that this time is good for the majority. And I think we're going to go back to this one. Yes, good. And I'm just going to grab something. And we can talk about it. So if you remember, I made, where is it? Here it is. To move on. Need it now. Not junk, I mean special projects. So we made, I made this thing with, you know, with support from the community. And I made 3 because, well, I didn't make 3. I had 3 boards printed from OSH Park, and I gave away the other 2. So I asked if people would like them, and I sent one off to Germany. YouTube pays me enough money, like, I don't know, enough money to pay for a postage stamp, I guess, like £5 or something. So it wasn't very expensive. So I can afford to send stuff out to people. Just for the sake of that kind of thing. So let's just see if I can find what Louis said. So it went to, now I'm not sure how you meant to say, L-U-I-S, Luis Diaz from Spain. So I sent it to him, and he was very thankful, and hopefully he's making it. He's not actually posted back and said that he's got it made, but he has sent me something from him and from his company. His company is BQ. Turns out to be something terrible, then I apologise. But I will click on it now and just have a look. I don't know what they do. So they are, BQ are smartphone manufacturers apparently, and he sent me something in the post. So let's just grab it. And this is it here. So we're just going to open it, but I'm not going to want to do that. I mean, you've already seen my address. I probably shouldn't say that, so people go back and find it on the stream. But I'll open this up, and then we'll see what he sent me. And he said it would be great if you could open it and record it on video. Also, it'd be great if you could name the company, which I have. I'm glad he said that, because I might not have done. I hope you can make some awesome things with this board. So I don't know what it is. I haven't opened it, I haven't looked inside or anything yet, so we're just going to see what it is. I'm assuming there's no letter or anything in here. No, that's just some delivery note. Just make sure there is nothing. No, there's nothing else, so we'll get rid of this because we know why we've got this. So he sent, hello. What is this? So this is a, I don't know. What is this? It looks like an Arduino compatible. So if I bring it a bit closer up to the camera, it looks like an Uno compatible. Hello. Look where my finger is just there, actually. That looks like an antenna of some kind. Or a motif, I'm not sure. And there's lots of extra headers here. I'm just gonna have a quick close-up look at what that chip is. Pretty hard to see. It's a Mega, that's an Uno chip, so that's a 328P. And it's the AU version because it's the one that's on the board. And we've got a couple of bits here. These are they, I can't, someone might know the footprint, but it's like B something or BGA? BGA, that's probably right. So he sent this in, which is lovely. So there's the bottom side of the board. We've got BQ, the ZUMBT328. So the 328 is specifying the chip that's on the board. So it's a, I'm gonna have to look this up. I'm not sure what that is. What did it say it was? A ZUM BT328. So let's have a little look. Okay, well we've got it here. So let's jump over to the screen, you can have a look. So this is, oh. this is it. This is the board. So it's a build your own ideas board. Let's see if I can click on buy. Let's go on that. So this is the board. It is Zoom represents a step forward for controller boards. It incorporates improvements and add-on functionality for groups. Well, those are the technical specifications, so it's not actually very detailed just yet. I'm going to go ahead and say it's probably a Bluetooth board. The BT would certainly suggest that. And it looks, we've got an on-off switch here. So that's to turn the Bluetooth on off possibly. I'm not sure. We've certainly got a large inductor there. Is there some kind of battery input possibly? I'm not sure. This one's a bit of a mystery to me, honestly. Pieter, is that how you say name? I'm not sure. You are in the chat. You've just said the chip looks like a Bluetooth one. It does. So we'll investigate this further later on in another video, I think. But for now, I'm going to just say thank you very much to Luis for sending this to me. It's really nice. It's got some nice, I mean, look at the holes all over the board there for mounting it and stuff. You know, this might be really, really good for the robot I'm trying to build. I want it to have separate motor control, so movement control from take all of that sort of processing load off the Raspberry Pi so that it can deal with voice control and with OpenCV for the camera. So all it would have to do is send some serial stuff to control the robot. But I wanted it also to be remote control. So this is very interesting. So I look forward to playing with that in the future. I think that is about all I've got time for today. So, the right one. There we go. I think it is about all I've got time for today, but I'm going to look at the chat quickly, and if you guys have any questions, feel free to ask now before I disappear forever, or till the next video stream, or whatever. Do you know, I think this one's gone a bit better than the other ones had before. I think I'll try and figure out the audio issue, isn't it? So I'll just have a quick look at the chat. If any questions, please feel free to answer. I'm going to post up the straw poll again, just in case anyone is here that hasn't seen this and would like to comment on when I should stream. Trying to talk and type is very difficult. There we go. I posted it up again. So I'll just quickly get through the chat. I'm really sorry. I know it's quite painful to watch someone just look at a screen. But if there should still be music going. I can have a little check. I do have some headphones, but I'm doing this without listening to the audio because I don't want it to distract me really. There is some music still going. There we go. You get a bit of more audio for a little bit while I read the chat, and then we're going to say goodbye, unfortunately. As much as I've enjoyed doing this, but I've sort of run out of content, so unless you guys have questions, of course. Dirk says it's Bluetooth, Bluetooth antenna. Yeah, you're right. In fact, I don't need my big face on the screen. Let's just back to this one. So you guys can have a look at the board and maybe try and figure out what you think it is. In fact, let's put it on something that's a bit higher up. Let's get my crappy little robot out. Well, it wasn't really a robot. Just so you can have a little bit of a closer look at it. And I'll read through the chat. Yeah, everyone thinks it's Bluetooth board, and I certainly post up another video once I get around to doing it. Rat Biker arrived a little bit late for the party. No worries, mate. You can always catch up. Like later on, it'll go live on YouTube in like half an hour or so, I would imagine. Audio is a bit too loud. I just, you know, you mess around with something and then something else goes wrong, of course. Keep in mind that the music was too loud for that last little bit. So thank you very much for coming. Really appreciate you being here. It's been a lot of fun. I would like to get some people on the stream next time, if possible. So if any of you have Google+, send me a private message on Google if you fancy having a chat about something. Give me a topic. We can, if you don't want to, it's just going to be a little hangout that I'll record and put up here at the same time. It can just be your voice if you want to, or if you've got any topics you want people to discuss, because honestly, I'm running out of projects now. Like, I need to get on and make them before I can show you any more. So next time I think we'll try and do something with some live interaction. Anyway, thank you very much for coming, guys, and I will see you soon. Goodbye.